which is equals to cap.read. So this will give us our image. Now, because we are doing this in real time, what we want to do is we want to reduce the size of our image, because this will help us in speeding the process. So we will write that our image small is equals to cv2.resize, and we will send in our original image, and then we don't want to define any pixel size, and we will write none, and then we will define the scale. So the scale we will put as 0.25 and 0.25, so it is 1/4 of the size. And then as you know, we have to convert it into RGB, so we will copy this and we will convert it into RGB. And then the next step is to find the encoding of our webcam. So here we can copy this. Now in the webcam image, we might actually find multiple faces. So for that, we are going to find the location of our faces. Then we are going to send in these locations to our encoding function. So to find the locations, we can use this. So we can write here faces in our current frame. And then we can find all the locations in our small image. And then our encodings, we will write encodings of current frame. And then we will send in our small image. And along with that, we will send the faces, the location of the faces. So faces, current frame. Now we are moving on to the third step, where we are finding the matches. So what we will do is we will iterate through all the faces that we have found in our current frame, and then we will compare all these faces with all the encodings that we found before. So to loop through, we are going to use both of these lists. And to loop through them together, we can write for. So the first thing we will find is the encoding. So we will write encode face. And then we will also find the location. So we can write in zip. And then we will write encodes of our current frame and the faces of our current frame. So what this basically does is, so one by one, it will grab one face location from the faces current frame list, and then it will grab the encoding of encode face from encode's current frame. So because we want them in the same loop, that's why we are using zip. Then we are going to do the matching. So we will write here matches is equals to face recognition dot compare faces. And then, as you remember, we have to send in a list. So the list of our known faces is basically encode list known. So we will send that encode list known, and we want to compare it with one of the encodings, which will be our encode face. So we will write here encode face. And then we are going to find the distance. So face distance is equals to face underscore recognition dot face distance. And then we are going to send in the same parameters. So encode list known and encode face. So because we are sending in a list to our face distance function, it will return us a list as well. So it will give us 3 values because we have 3 known faces, and it will give us the distance of each one of them. So the lowest distance will be our best match. So let me show you what I mean. So if I print face distance, this will be a list. I actually didn't connect my webcam. Let me connect the webcam so we can run this. So now I have connected my webcam, and as you can see, we do not have any output because we are not showing the webcam image. But if I bring my webcam near to a Bill Gates image, you can see that it starts giving us values. And as you can see, the value at the first element is the lowest. So because the image I'm showing is of Bill Gates, that's why we have the lowest one at the first element. And the second and third are for Elon and Jack Ma. That's why they are higher values. So what we have to do is we have to find the lowest element in our list, and that will be our best match. So to do that, we can write match index is equals to numpy dot minimum at our face distance. So this will give us the index. So in this case, it would give 0 because this is the first element. If it was this, it will give us 1. So once we have that index, now we know which person are we talking about. So what we can do at the end is we can simply display a bounding box around them, and we can write their name. So to do that, we can write if matches, and then we can write index, match index, and then here we can write our name is equals to class name at our index. So match index, and because it's a name, we can convert it into capital letters in case the name is in lowercase, so we can write upper, and we can print this out. So print name, and let me run this and see what happens. So here, if I bring the image close to Bill Gates, and it will say Bill Gates. So what we can do is we can create a bounding box around the face, and we can write the name. So to do that, let's first show the image as well. So we can write here cv2.im show, and we don't want to show the small image, we want to show the original image. So we will write here webcam, and we will write here image, and then cv2.weight key is 1. So if I run this, there you go. So you can see that we have the image of Bill Gates, and it's giving us Bill Gates as the output. Okay. So in order to create that rectangle, we need to first find the location. And because we already have done that, because we have all the locations, what we can do is we can say y1, x2, and y2 and x1 is equals to face location. So this face location is basically this coming from our locations of our faces. So then we are going to draw a rectangle, cv2.rectangle, and we want to draw it on our original image, and then we are going to write here x1, y1, and then x2 and y2, and then we are going to give it a color. Let's give it green, so 255 and 0.